Cool. So starting off, something that I kind of live by is that we can have nice things. If that's like a really shocking statement, hello. I would really like my slides up there. Hey, there they are. We can have nice things, like slides actually working. I think as we look at some of these topics, the nice parts about what we build and what we do on the web kind of get thrown to the sides for functionality over form. And as someone who went to school for art, like, you can't get rid of the nice designs, the really good visual graphics and interactions. To me, that's just ruining everything. And then we work at Megacorp. So we're going to be talking about delighting users with performant apps, diving into UI performance. What are some things that you should look out for? What are some things that you should be aware of? And how to mimic what native apps do, but with the web. Mike Hartington, I work at a company called Ionic. You can find me on Twitter, Hartington. And this word performance is kind of a complicated subject matter. You can throw word performance around to a room of 10 developers and get 10 different answers. And you're also going to find people who say performance is only about one thing, and one thing only. Truth is, performance is a very broad topic. You can be talking about how long it takes your app to boot up. Boot time, parse time, however you want to talk about it. It could be network download time. Are you sending a megabyte of JavaScript down to your users? Probably don't do that, but that's a performance metric. And then also, how long is it taking until your app actually renders something to the screen? This could be a new bit of UI, an overlay, a pop-up, something, whatever. That is what we can think about as paint time. There's a lot of good acronyms that people will throw around for this. Largest contentful paint. I'm sure if you go to any Google resource, you'll see LCP, ICP, random stuff like that. But what we're going to be talking about is the UI and UX features and how we can measure those performance metrics. So we're going to be looking at how we can animate things inside of our app, do it in a way that is actually fast. We're going to be talking about updating the UI and doing it in a way that's going to maintain the high frame rates, and doing operations inside of our apps that won't block the main thread, and also be resilient to multiple streams of new bits of data, so that way it's not doing extra work. So, preface this is all really hard stuff. This is not going to be easy. This is not something that you can just go, oh, I know this stuff. It takes a lot of work to understand how to not only just implement it, but to know when you've messed up. No one's going to look at your app and say, hey, you're doing this. You have to actually profile it. You actually have to open up DevTools and see, because I did X, Y, and Z, I can now have some kind of notation of how slow my app is. It's not going to be an overnight thing. This is going to be a constant journey of learning how to do this well and keep your performance up. Now for me, given the work that I do at Ionic with a lot of native apps, this is a term that I hear or a phrase that I hear thrown around a lot is, it doesn't feel native to me. And this, I think, really dives down to UI performance versus anything else. Because native apps have a really good knack of showing stuff and having fancy animations, smooth scrolling, widgets that just go ahead and, if you think of a tweet, you hit a like button, you have now this whole animation in confetti as the heart lights up. Most of that stuff is actually built into the platform, and it really feels like an unfair comparison because it's just given to them for free. Developers don't have to do all of the work to profile it. They just say, hey, iOS's animation class, go ahead and do this. And so I had about 2 years of free time, and I decided, hey, let's go profile a native app really break it down into its essential parts, and understand what it's doing, and see if we can redo that in the web. So I took Apple Music. Most people probably use Spotify. Concepts are pretty much the same. It's going to play music. But what's going to be different about it is that I think Apple Music has a better design, plus some other reasons. Apple Music has these really unique features that I think stand out against other music apps, but it's really stuff that if it wasn't there, it just wouldn't feel like Apple Music. So like this play and pause kind of cycle where the album art scales down and then the shadow kind of disappears, but it's not like an opacity change. It's like a full morph of the shadow into something that is simulating that really low to the ground surface shadow. As you go through and you are going to the next song, I'll wait for the animation to do it. Yeah, the background of the player actually updates to reflect whatever the album art is. And then as you toggle your cue for songs, that animation kind of just feels so natural. They're really key things that if that wasn't in Apple Music, I don't think it would be Apple Music. It'd be just another music app. So we're going to rebuild this with web technologies, with JavaScript. We're going to break it down to that animation for the play pause kind of feature, the dynamic background updates, and then handling animating complex layout structure. I built this app using Ionic and Angular. You do not need to use Ionic and Angular. You could use no framework if that's how you want to roll. The ideas and the framework implementations really don't matter. It's all about the principles that we're going to learn. So you can apply this to React, Vue, Solid, Svelte, whatever framework comes out today or tomorrow. So animating the right things, we're going to focus on that play pause part because that is where, if we don't do this right, it's just going to go downhill real fast. And it's going to be talking about creating that sense of elevation. So just to recap what that looks like, we have a song, it's playing, we hit pause, it goes ahead and the card shrinks down, and then that shadow kind of morphs into a different kind of shadow to simulate that sense of no elevation. Now, I thought this was going to be super simple. I'll just go to material design, I'm going to copy some CSS I found on the internet, and boom, I'm done. And I did that. That's not a knock at Google material design and everything. That's actually a really good resource for reference for elevation. They have this legit, really good reference of, here's something at elevation step 1 all the way up to elevation step 16 and how that shadow morphs. And it can be a really good visual reference. Don't copy the code though, because this is what you're gonna get. And it's gonna be kind of hard to, it's a little bit easier to see, but you can see that the shadow in here, it's on just an animation, keyframe animation, so it's morphing between two different drop shadow values. They're a multi-part drop shadow, so there's 3 implementations of it, and then as the time progresses, I'm going to a different version of it. Don't do that. Don't do that ever. Drop shadows are terrible for performance. And it comes down to how the browser actually has to handle a shadow. For us, it's just a shadow, but for the browser, it now needs to go, I am at this point in the drop shadow. I need to now calculate the colors that are going to be referenced in the background color plus the shadow kind of mutated together. So while one shadow on a page might not be that impactful, having an animation that involves shadows is going to be terrible, because now every step of that animation is going to need a new calculation. It's called, I believe it's repainting. As you're doing this, if you're on a lower end device or an older device, you're going to start to hit your CPU a lot more frequently, which now we're causing an energy impact. So with one shadow, we could probably let that animation run for, I don't know, an hour, and we would see a noticeable drop in the battery. So don't do shadows. We can actually see this too. And while this is on a recording, it's probably easier to just show this in Chrome. Well, Edge for me. So here's the app that we have, and here's the shadow. It's a little bit clearer to see now that it's red. Let's go, and inside of DevTools over here, we're going to go up to, where is it? Rendering. Now, rendering is a special tab in Chrome Tab Tools that'll give you a whole bunch of like flags that you can enable to see your rendering performance. So let's go here and click this paint flashing. So as that shadow animates, we can see all the affected areas, even though our shadow isn't fully being shown there. All of that stuff is getting repainted, and it's unnecessary. Now, while this is really good for, say, a desktop environment where we have faster CPUs than our mobile devices, we can simulate this by going to the Performance tab and going to CPU throttling, and assume worst case, we can go to 6x slowdown and then come all the way to performance monitoring and see how this impacts our app. We'll zoom in again just to make sure that that comes in clear. Our CPU usage is skyrocketing. You can see that one big spike, but then you can also see that it consistently stays at about 30%. Style recalculations is actually better than it had been in the past, but we're doing 60 style recalcs every second, which is not the 60 frames per second that I thought I was looking for. This is bad. Terrible. If you have a drop shadow in your app, do not use it. Now, the code for this is, like I said, using a keyframe animation just to simulate the effect of having that play pause, almost a stress test. Right? We have our 0% and our 50%, and you can see the two values that we're changing between. Now, a shadow itself is not that complicated of a thing. Has anyone done Photoshop before? Okay, what do we do if we want a shadow in Photoshop? Duplicate it and drop it down. We are essentially creating a new layer, right? So instead of using a box shadow as CSS, why don't we just create a new element and then paint it black, do a blur, and then we can use another approach to animate it with transforms. So let's go up, and we're going to comment this out. And down here, we'll do this, and we'll go over it real quick. Instead of that, we're going to use a pseudo element. We're going to use the after element. Pretty simple pseudo element stuff. Set the content with height, background to 100% red, and then we'll do this animation and filter it with a blur, and then we're going to transform that. Now, instead of having to mutate that between two different box shadow values, we are just going to transform that. Very simple. But let's go ahead and save. And we'll come back over, let that reload. Performance monitoring. Okay. And let's open that up. And now, okay, that shadow is there. I promise you. It just looks very tiny for some reason. But you can see that our performance, while it's not perfect, like there is still like a little spike here and there, it's far better than what it was before. And if we go over to that rendering tab, you can see we still have flashing enabled, but we're not doing any recalculations. Like that is amazing. We have a shadow in here. Demo gods be damned, it doesn't look perfect, but we can do the same thing just in a slightly different approach. So just because I was prepared, we have the same demo in here. I'm not going to make you watch that, but we can go over to the code overview to see how this works. So again, we have the keyframe, box shadows. Don't ever do this. If there was an ESLint rule for CSS, Josh, free idea. You could go ahead and say ban drop shadows or box shadows. That'd be great. Instead, let's use a pseudo element, and we're going to use transforms. But our original shadow is actually really complex, and we only have before and after for pseudo elements. So if we're using things like custom web components or custom elements inside of your framework of choice, you could wrap this up and use something like multiple divs. That's really all they need to be. And then you can have a complex shadow that gets adjusted as your animation changes. So there's a lot more that we can do with this. Much more freeing, in my opinion, than using a box shadow. So with that in place, we can see it here again, super smooth performance, very similar design aspect, and it's not causing all these recalcs. So we can animate the right things by just making sure we are doing stuff that is not going to cause style recalcs, it's not going to attack our CPU. In fact, what we're going to do is close this, because what you can't hear is my laptop's fan kicking on. It was that bad. Okay, so to our next part, we want to handle dynamic and unknown animations. And this is going to be that cue change. This was something that was really, really difficult for me to actually understand how to get it to work. Because with animation like this, we're hiding and showing a div or a bit of UI, and as that animation changes, we now also need to handle when it's either hidden or removed from the DOM, which can cause a layout shift. So in this case, the animation that we're trying to recreate, main part, is moving to the left. Pretty easy. The other part, it fades in, and it has like a little transform in it too. You can see it like kind of scale up a bit. We want to recreate this. So in trying to do it the first time, like I said, as you would get one portion animating right, you wouldn't get the second portion animating right, because you're now having a big layout shift. And any of your predefined animation values are not going to reference the same XY values. I almost gave up on this, and then I found this really great article on flip animations. It wouldn't be a web feature if it wasn't an acronym. It stands for first, last, invert, and play. It's just a way to think about how you orchestrate complex animations. It's actually a lot simpler, but it can be a little bit confusing when you actually get into it. But the concepts are, you have an element, it's somewhere in space and time, get a snapshot on it, you use get client bounding rec, which is a very wordy function. It'll give you the X and Y, width and height, all the detail and layout information you need. Now you cause a layout shift. This could be adding a class to your parent container, or you are adding elements to the DOM. Now that element has moved its position, let's get that information too. Now we know the beginning and end, our animations become a lot easier. We can just do some basic math. Most of the time it's subtraction. And then once we get those values, we're just animating it essentially back to where it was originally, and then just letting the animation play through to assume its ending position is what we are animating to. It's kind of a trick, but it's not, but it's also pretty cool to see in how it works. So we're going to dive into a simplified version of how this works inside of my app. Do not worry about it. We will see the real stuff and see how hairy it can get. So starting off, we want to get our two elements here. So we have a queue, player queue, and then the actual player itself. We're going to query that, and then we're going to get that layout position. I alias get client bounding rec to get rec, because that is easier to type. So that's going to give me my X, Y values. It's going to return all the position and everything, and then we're going to cause that layout shift. This is adding a class. My layout is now completely different. Get the layout position again. Now we can start to do the math to understand where are these elements going or coming from, and how do we want to animate that. So for the first one, all we're really doing is just subtracting the width and height to get the translate values. And then we're also, apologies, I went to the wrong one. This is actually doing a quick little comparison to just say, hey, was the width 0, meaning it was set to display none? Okay, animate it from 0.8 to 0.21. Was the width anything greater than 0? Okay, go from 1 to 0.8. That's all that needs to do. And then the X and Y are just going, for the player itself, are just going to be get the before and after values and subtract it. This is using a function inside of Ionic. That's the only thing that's specific to it. You can still do this with the built-in Web Animations API. We are creating a from-to animation where we'll just say, hey, it's at this place, animate it from this value, and just let it happen. And we'll do the same thing with opacity too. And then for the player itself, it's a much simpler animation because it all it does is go left to center. So our animations can be just animated from this original position back to what it's at now. And all that together gives us this. Now, the animation comes in. We have the track player going to the left a little bit and then coming back when we close it. The animation for the entrance works and looks great. For the exit animation, it's not perfect. I did go back and fix it, and I will show that code. But now we have this whole reactive kind of animation system without having to know exactly what values we need to animate, which means that we can now start to be fancy and do some media queries in our JavaScript to have completely different animations for when we are in a portrait mode. Pretty awesome. Now, the actual animation it's a lot. It's 266 lines of code. The animation does have some little helper functions here and there, but what we do have is inside of this first animation block, we essentially need to figure out where this element is and then set its position to absolute to start to do more complex transitions. Because we have a layout shift when elements are set from display none to display visible, we now need to account for that. So we get those before and after values, and then we set position absolute and actually hard code their values, and then go through and do the animation. And then in a cleanup function, we remove all those inline styles. It can be complicated to figure out how to do this. I think I spent like 2 days trying to understand why it wasn't working, only to realize that position absolute is a terrible, terrible thing. And browser layouts are anything but inconsistent. So all this together gives us a much more accurate animation to what the original app has. And we'll just show it. Actually, no, I'll wait until afterwards. I'm just making this up as I go. So the animation for this, like I said, was using Ionic's own animation API. You don't need to do that. In fact, the web animation API could totally have pulled this off. And there's actually a really easier solution, and that is to just use GreenSock. GreenSock actually has a flip plugin as part of its library. And all you really do is give it the elements that you want to animate, and an easing and a timing function, and afterwards, any changes to that will start to do the flip animation. It's really cool, literally just like a one-line function that you add in your projects, and you get this kind of layout animation for free. Or you could build it yourself. Dynamic and unknown animations, we got that done. What about this reactive background change stuff? So doing some work to make sure that the background color matches your album artwork probably is not a smart thing to do, because now we have to do image analysis. And there's a lot of math involved with that. Just to make sure that we're all aware what that is, as we go through the queue, we are now just updating the background to make that match. There are some libraries out there that will do this for you. A lot of them can be server-side specific, but there is one that does work for the browser called Color Thief. It's a relatively older package. I remember using it in like 2015. So it's popular enough that it has not gone away. And what you do is you give it an image, whether it's an image URL or an image source, and it will go through and calculate the colors in that image and then return you an average of what color is the most dominant. So in this photo of some carrots, celery, a sauce, and I don't know what the other thing is. The dominant color in this case is the blue from the plate, which makes sense. When you look at it, you can just see that blue is pretty clear. But it'll also return additional colors that are secondary, tertiary, however far back you want to go. So that way, if you wanted to do like UI that is based off of an image that you upload, you can get all these colors off and then start to theme the rest of your app. It's actually really cool. It does run in the main thread, and it can be very slow if you have a large image, because now it has to go through and calculate every single pixel in that and figure out what the average color is. So I decided to try to port this over to something that could run in a web worker. And like I said, I was using Angular before, so I have a directive that will just listen for whenever an image source changes, pass that data to the web worker, and then I get the color back that is the dominant color for this. So our directive for this, or our observer for this, is basically going to go ahead and watch for that image source change. We do some quick little logic to like check to see if this is an actual different image. Apple Music is really weird. It'll return the same image 3 or 4 times, just with different query params at the end of it, and that can trigger your image source, like your image change, to refire, even though it's the same image. So we do some quick little comparisons for this, and then we call this getPalette function. Now this getPalette takes an image, gives you a color count, and then also a quality. So how fine of a sampling do you want to get in? We can set some default values, and then we're going to go ahead and create a canvas. We'll put that image in a canvas. We'll get the data, get the pixel count, and pass that over to a web worker. Now the web worker is going to go through, it's going to take all of those pixels, it's going to take all of that data, and it's going to just start comparing every single thing in here to say, yes, this is the dominant color, and here are all the subsequent colors. We'll pass it along, and when it's done working, we can then go ahead and say, worker, send that data back to the main thread. We can get that in this onMessage handler, and then emit that in some kind of event. So this is a really kind of simple way of handling data back and forth when you know that the worker is not going to need a touch like the DOM. Most people show off the Fibonacci sequence in a worker, which I think is totally not practical, but image analysis in a worker, very practical. And just to make sure that the worker, to show you what it is so much math. It is so much math that it's not even funny. I don't even understand half of this. This is all just copy and paste from Color Thief with some types added because there were no types in it, which is very bad. But the part that actually matters is this add event listener. So all of this is happening up here to just quantize the image and the colors. We pass in that pixel data. We go ahead, we create our multifunctional array, so an array of arrays with RGB, and then we pass that back. So while the actual details of it kind of aren't that important, passing data back and forth and how that gets processed can be done off thread and not ruin my performance. And all that together gives us this. So we're going to a new song, the image is already updated. It becomes really obvious when you go to a completely different color. And if I were to go ahead and just start hitting next, next, next to get a new song, there's some logic in there to make sure that it's debounced. So that way it'll wait a second before trying to process anything else. So all of that together gives us a really nice experience that feels like it's adapting and it's matching our content. So, oh God, I'm ending pretty early. But putting this all together, it's up live right now, and we're going to look at it. If you go to startrack-ng.web.app, you can get the actual example. You can even log in with your own Apple Music account, but most people don't have Apple Music. I do, though. So I can log into it. And the app itself looks like this. So we're pulling in all the top albums. Obviously, Taylor Swift's is #1 because why not? We have some playlists over here, but I'll pull up a playlist that I like more. I think everyone probably has seen, not that song, but everyone has probably seen this face before. Yeah, it's a, let's go ahead and get that speakers out. Let's just play this. It's not essential to the presentation, it's just nice to listen to and be relaxed. Let's go up and open up our player, right? We got the music in here. We've adapted some of the background changes to be more accurate to whatever this is. So if we were to go to the next song, it's a lot more smoother, feels right for the album art. We can play and pause and know that the shadow is super smooth and efficient, but let's keep the music playing. And then we can go to our animation over here, and you can see like the leaving effect where it just scales it nice, scales it back, and you can just sit here doing this all day. It's really fun. But we'll let the music play and we'll close out a little bit. Yeah. Got it? I'll get out of the way, I promise. All right. So, wrapping up. We can have nice things. Our apps can be fun, it can be engaging, and still be fast. We don't need to throw out all the good parts that our apps should have in the name of performance. You can be smart about how you are animating things in your app by potentially using Flip. You can use the right kind of approach to adding shadows to your app without using box shadows. Again, ESLint rule to ban box shadows in CSS, or even a CSS parser for ESLint would be super cool. I would love to have that. And web workers, you might not think you have a need where a web worker could be important. Web workers are super powerful if you know what you're doing and you know how to incorporate them into your project. I'll tweet out my slides, but thank you so much for hanging out for like 45 minutes. I'll see you all outside and probably at the social, but thanks. Okay, are there any questions? Question up front.
Yeah, it's a pretty silly question, but do you find yourself obsessed with like timing of things?
Yes. Did I find myself obsessing with timing of things? I would record the segment in the native app and then import that into like Final Cut and step through it to try to figure out the duration and then also the easing. The good thing is that Apple actually uses enums for all of their timing functions, so you could just like look it up and get like the exact timing function for everything. I did have to modify it a little bit because it's not perfect, but yeah, I would analyze that stuff obsessively. I had 2 years. There was a pandemic. What else was I going to do, right? Any other questions? No? Yes. Adding what? Yeah, a little bit here and there. There's a reason why I'm not a designer anymore. So the more stuff that I try to do, the worse it's going to look. The less I do, the better. So I had done some versions of this, and I'm not even going to try to look it up because it's embarrassingly bad. So I didn't try to do that for this one. So, cool. Yes? Yes, actually, not a full WebGL implementation, but the background for that glow effect for all of this is now a canvas. So as that canvas is getting the images, we're drawing that image data, and then we can transition between the old image and then the new image and just animate that kind of frame by frame. So all this to do that. But shout out to Ken Wheeler, who, when I asked him about this, just DM'd me an example and goes, "I got you, boy," which feels very Ken Wheeler-like. Cool. If there's no other questions, you're good to go. Bye.